Hello. Good evening, honorable present here. Ladies and gentlemen, it is my pleasure to welcome Ms. Ramita to our platform. Ramita is highly qualified, an accomplished individual, holding a BE degree in electronics and communications, and master degree in space engineering from University of Surrey. He has also completed a project management for scientists and engineers course from University of Oxford, United Kingdom. Ms. Ramita is currently the former CEO of Accident Satellite Technology LLP, which is specialized in payload design and system design of cube and micro satellites. And Ramita specializes in the cube and micro satellites, payload design, system design, electronic system design. He has remarkable record of achievements, including being involved in South Asian satellite design as a part of PTCU, successfully delivering electronic system design projects for clients such as Intel, Dell, and SanDisk via Wipro Technologies from 2004 to 2010, being recognized for a patent area while consulting at Dell. Consulted with a number of British companies, prominently with the British Aerospace and Concurrent Technologies. Designed the mission system computer for a combat aircraft at British Aerospace, awarded first prize for designing a moon rover in the prestigious CubeSats competition during her master's in space engineering in University of Surrey. Designed a payload interface computer tool of AARESC satellite mission, the collaborative mission between Arctic University, US, UK, and IASC India, and working on various commercial CubeSat missions, and continues to contribute towards student skill development in space sector. We are honored to have Ms. Ramita with us today, and we look forward to hearing her insights and perspectives on the topics that are coming. Thank you, ma'am. We are welcoming you.
Thank you very much, sir.
Ma'am, you can start your session on this.
Okay. Hi, good evening, everybody, and my hello to all the distinguished guests present at this occasion, and thank you for giving me this opportunity to speak to students. And yeah, it's good, that with the technology from different locations, we are able to communicate with each other. I'm not able to share my screen.
Yeah, we made a co-host, ma'am. Can you try it out?
So it is like who can share the screen? Host only or all participants?
That's all participants. Only 2 participants only. Can you share now?
Yeah, I'm able to share. So can you see my presentation?
Go ahead.
So today we are going to talk about the CubeSats and numerous opportunities we have for developing of student satellites. So basically on the various kinds of payloads available and the new technology trends which can be built using CubeSats. So coming to student satellites, there have been various student satellites in the past which have been launched by ISRO, and each of these CubeSats do have unique payloads and unique capabilities that have already been launched. For example, Sat is the smallest CubeSats which is launched in space so far. It is just a little bigger than the coin which we have. And like Pratham Sat was developed by IIT Bombay, which had a payload for measurements of electrons in the ionosphere. And so same way, like NIU SAT had a payload of camera which can capture images in 4 different spectral bands. So this way, there have been very few student satellites which have been launched in the past. And the Unity Sat was launched through ITCA in February 2021. And through ITCA, we are getting huge opportunities, and through the 75 student satellite mission, that the CubeSats can be launched here. This is the opportunity for students from all over India to design their own satellites, create a new kind of payload, which is based on research. You have various options for research on CubeSats, and you can launch your CubeSats through 75 student satellite mission. So usually when we say satellites, so previously it was only based on huge satellites, which was usually designed and manufactured by government organizations like NASA, like our own ISRO. So all the satellites were kind of tons of kgs. So satellite classifications is also based on the weight of the satellite and how big the satellite is. So more than 1,000 kg of satellites was previously used for different purposes. And the other categories is between 500 to 1,000 kg, 100 to 150 kg. The micro satellites are like 10 to 100 kg, and nano satellites range between 1 kg to 10 kg. So here we can see in the picture like how drastically the size of the satellites have been reduced, and that is how we are able to access working on the satellite technologies. So usually like the private sector organizations are in the space field in India, both in India and around the globe. They are trying to work with nano satellites which range from 1 to 10 kgs and micro satellites which range from 10 to 100 kgs. So coming to CubeSat, it is a small satellite, which is built in a 10 centimeter by 10 centimeter and by 10 centimeter cube, which is as equal to somewhat little bigger than the Rubik's square, which you may have. So it is a miniature miniature satellite, which can be used for various kinds of missions like technology demonstration, to demonstrate a new technology which we have developed, or a science experiment to be performed in outer atmosphere, and for educational purposes, and also for commercial satellite purposes. So this one new CubeSat, the beauty of it is like it can be used as a modular one. So it's stacked 2 of them together, it forms a 2U satellite, and it can be stacked up to 24 units to form bigger and bigger satellites. So the advantages of building CubeSats is like it can be built very rapidly, from 9 months to 1 year, or within 1.5 years, depending on the kind of payload or depending on the kind of satellite missions. So it uses very simple technology and compared to bigger satellites, which I showed before, and that way students can participate in building this kind of CubeSats. It is simple to design. I mean, at least simpler than the huge satellites. And one of them is like in CubeSats, we can easily have deorbiting techniques, which is easier to bring down the satellites into Earth's atmosphere and burn them down, so that we don't leave it as a space debris. So these CubeSats, after a few years, because of their smaller size, they automatically drag down to the Earth's atmosphere due to Earth's gravity, and thereby they do not cause debris. And one more major advantages of CubeSats is they can be developed in much lower cost than the traditional satellites. So the main purpose of CubeSats is to provide access to space for everybody, irrespective of whether they are students or whether they are from university or a research institutes or private space sector. Because CubeSat can be developed with reduced cost, with reduced development time, and which increases the accessibility to the space, and we can have multiple launches, because it takes about 1 year, very less time to develop an entire CubeSat, between 1 to 2 years, compared to huge satellites of 100 kg to 1000 kgs, which takes about 5 years, anytime, anywhere between 3 to 5 years for complete development and launch. So CubeSats are usually launched in lower orbits, like anywhere after 100 kilometers up to 2000 kilometers. But student satellites are usually launched between 400 to 800 kilometers. So the life expectancy of a CubeSat is only between 6 months, but it can go up to 5 years depending on our design. So the major advantages of building a CubeSat is it is low cost, which is smaller in size, lesser development time, less launch cost, and it can have it can sustain frequent launches. So we all know by now, like what consists of a CubeSat platform. So usually the CubeSats is defined by having a payload and the payload interface to the onboard computers. A communication unit, which is mainly of either LoRaWAN or a UHF VHF frequency transceiver unit that can also provide point-to-point communication. So attitude determination and control for a small 1U CubeSat is nothing but just having a sun sensor to track the satellite. And when we have a bigger satellite like a 3U CubeSat compared to a 1U, we can have kind of 2-axis or 3-axis determination for the platform with the help of reaction wheels, smaller reaction wheels, and magnetometer and magnetotalker kind of devices. And the electric power system is usually through solar panels and the batteries, which provide constant power for the satellite. And there has been new technology which is in development in terms of electric propulsion as compared to the chemical propulsions or solid and liquid propulsions which we used to have before. So what is very important in a CubeSat mission is the payload itself. So the payload determines the satellite mission, like the reason for why the satellite is being launched. So what kind of payload, what kind of data the payload is going to generate, how big is the payload, and how much power is required for the payload. So depending on all of these features, and also what orbit the payload has to be, or the satellite has to be launched to get the proper functioning of the payload. So all these factors of the payload, they influence the design of the spacecraft in terms of, depending on how big the payload is, we determine how big the spacecraft or how big the satellite has to be. And what kind of communications model should it have? So is the payload data less? Can it be accommodated in a UHF VHF satellite, or whether we need a communication of higher frequency bands? But usually student satellites are built in UHF VHF frequencies. And depending on mass of the payload, the mass of the entire satellite mission gets determined. And similarly, the power generation, and it has impact on mission cost. So overall, the payload of the CubeSat mission is very important. So there are different payload types. So primary payload is the reason why the satellite is built in the first place. So suppose you are building a communication based satellite and your payload is a communication satellite, and you want to have a additional feature in the in your CubeSat, something like adding a small camera. So that way the small camera becomes the secondary payload in your CubeSats. So it is just, and then you can have lot of payloads which can be flown in a single satellite. Like for example, suppose you want to develop more types of payloads, like 2 or 3 types of payloads from your university. They can be launched in a single 3U CubeSat instead of launching 5 different CubeSats. That is known as hosted payload, which kind of brings down the cost of launch so that it is also called as ride share kind of payloads. Now, payload, what is a payload? Payload is something which defines a CubeSat applications. So there are various kinds of CubeSat applications for which the payload is developed, and based on what your payload is, you design your CubeSat accordingly. So like few examples are listed over here, and this list is very limited list, and there is no limit for the kind of imagination and the research you can have with different CubeSat applications and building those kinds of sensors and payloads accordingly. So Earth observation payloads is something which we use to observe the Earth from a higher distance. Like for example, observing the vegetation, the forest area, observing the water levels or flood situation, or observing the forest, the oil and gas, and it's the use for mining and other kinds of purposes. So usually the payload for a Earth observation application is cameras, which are, there are different kinds of cameras like infrared cameras, hyperspectral cameras, and used for like SAR imaging technique, and each of these techniques are used to determine different kinds of applications and different kinds of images through the satellite. So similarly, remote sensing applications are something which measures or a instrumentation kind of payload. For example, Pratham satellite had a payload for measuring the protons or electrons in the ionosphere area, or we can have sensors for measuring atomic oxygen in the upper atmosphere, or measuring a methane gas in the atmosphere, measuring the pollution levels, like which was kind of payload for the Satyabhama sat developed in Chennai. So remote sensing are very popular payloads for student satellites. So similarly, we can have different applications like global positioning system and communication payload. Like with a combination of GPS system and communication payload, we can have something like ship tracking and aircraft tracking possible. Robotics is something we can develop a robotic arm for the satellite, like the International Space Station has the robotic arm, and we can use robotics for space situational awareness and cleaning up the space debris. There are a lot of microgravity applications, astrobiology applications, and these kinds of experiments which are constantly happening in the outer space. So we can develop different kinds of payloads in these domains as well. And artificial intelligence is another emerging technology in which you can pay the you can develop your payload on, and you can develop a lot of different algorithms, without even launching the application, using the satellite data. And each of these applications can again be upgraded to something called as CubeSat constellations, where all of these satellites are kind of performing the same activity. It has the same payload. It has the same kind of measuring unit, but we are using multiple of these CubeSats in a particular format. So the advantage of having CubeSat constellation is, one thing is it gives us the global global coverage. So for example, if we are taking pictures of forest area, so it takes the pictures of forest area in the entire globe using many satellites which are flown in a particular format. And then second thing is it gives 24-hour access, that is we can get the image in real time. And then it has like 24 hours coverage area, like the global coverage area. You can conduct your same experiments at different parts of the globe using the constellations. And then, for example, for providing broadband services using a little bigger satellites, so constellation are very useful. And famous example is for CubeSat constellations is the Starlink, which probably you can see with your bare eyes if you use the if you can track with the app. So the main important for us is like thinking inside the box. So what unique missions can we design, or what unique payloads can we design, which we can fit into a small satellites or a 1U to 3U CubeSats, and so that we can launch and conduct the experimentation. So like I can give you examples of the kind of innovations which is happening from 2022, and lot of startups have been working on these technologies, and it is not limited to startups. Like the universities can also start doing experiments or come up with new kind of products on the same thing. Like for example, satellite internet of things. So this payload we can easily build using a 1U satellite. So if we take spacecraft propulsion, we can build a small propulsion unit for a 3U CubeSat, and we can launch it as a technology demonstration mission. Like advanced ground system which use kind of wireless antennas, and in orbit servicing where we for example, we can provide refueling for the existing satellites. As I said, artificial intelligence, lot of algorithms can be used based on the satellite data which can be used in the ground station. So additive manufacturing is about learning new methods of manufacturing at lower costs, which can sustain space and space radiation, and also research on new materials which can sustain in orbit. And this is kind of top 10 innovation trends for 2023, which again, it's based on research performed in various startups and emerging companies. And so it is like miniaturization of bigger satellites, and space-based activity management, and space mining, as I said before. So space traffic management, developing a smart propulsion unit that can be kind of used in smaller and smaller satellites and constellation of satellites, like research on advanced communication like phased array antennas, or having patch antennas or wireless antennas that can be used in a constellation of satellites. So the importance of a student CubeSat is like, one thing is it is, as I already said, it's a very low cost and relatively quick turnaround time. It takes only few months or 1 year to develop a nano satellite and launch it for education purposes. So it gives lot of experience and hands-on training for students and young engineers who are trying to build a satellite. And why students involving in space technology is important is they are the next generation scientists and next generation researchers, which is very important for kind of space technology, which is a emerging technology domain. So it is like using tiny satellites, we can perform big experiments. Using these tiny satellites, we can make a huge impact. We can come up with unique payload designs in various domains. And even though it is restricted by volume and power, we can still achieve a lot of things. The box is the key over here. So one important aspect I want to cover is the space debris. So because people from all over the world are launching a lot of the satellites, here we can see around the earth there were only very few satellites. By 2005, these white dots are the number of satellites which have been launched around the earth. So we can see the increasing number of satellites which have been launched around the earth. So eventually it is going to the satellites are going to overcrowd the earth, because the amount of satellites which have been designed for terms of whether it is universities or whether it is private organizations or the government organizations. So it is kind of overcrowding the outer atmosphere and overcrowding outside the earth. So we need to have various techniques to preserve space, similar to we try to preserve our earth. So this is also an opportunity for students to work on the space debris, and kind of detecting and capturing space debris, getting them down to the Earth's atmosphere and burning it, and developing different kinds of deorbiting techniques in your university, so which can go on different CubeSats by default. So what this deorbiting techniques does is it kinds of brings down the satellite to the Earth's atmosphere, and when it enters the Earth atmosphere, it automatically burns down. So that way we don't leave any debris in space, because these debris kind of very tiny fragments which can destroy your current satellite and other space exploration and space travel if needed. So through today's presentation, what I want to say is that sky is not the limit, because using miniature satellites or even small CubeSats, it allows us to conduct our experiments beyond low Earth orbit. That is, we can have the CubeSats revolving under the moon, which is called lunar orbit, and also kind of we just like we have satellite constellations around the Earth, we can plan satellite constellation around Mars, Moon, and Venus as well. For example, the Artemis mission to Moon by NASA had several CubeSats, which was kind of rotating around the Moon. So that way, like the sky is not the limit. The kind of experimentations you do in the CubeSat, there is no limit to it, and you can achieve bigger things, like bigger kind of payloads through smaller CubeSats to it. So thank you very much. So if you have any questions, I can take up to 3 questions, please.
The session is open for questions. As there are no questions, we are having this session. Thank you, ma'am. Thank you so much, ma'am, for connecting with us.
Thank you so much and have a nice evening. Thank you.
Thank you, ma'am. Thank you.